This is our team members Muhammad Khairul Asrik bin Nurizam, Ainur Adila binti Hamdan, Nina Humaira binti Nihazisha, Nur Amira binti Maulud. Our case study is application of determinants using Cramer'S rule. About introduction, Cramer'S rule is a method for solving system of linear equation. It's find unique answers for each variable by expressing their solution as a determinant ratio. It is useful for small system but get proportionally expensive as the system get complex. The determinant of the coefficient matrix must be non-zero for a unique solution to exist.
For the purpose of study, the first one is to find the price of each biscuit that Amira, Khairul and Humaira buy by using the most acceptable method, which is Cramer'S rule. The second one, to solve the problem using the system linear equation. The third one, to form an augmented matrix that represents the system of linear equation. And the last one is to find the total amount of money that they must buy for the biscuits. Let's begin to the next one, which is problem statement. Famous Amos gave a discount in conjunction with last year's. Mrs. Aina let her child buy Famous Amos biscuits. Mrs. Aina's children, which is Amira, Khairul and Humaira, want to buy double chocolate chip macadamia and original chocolate chip. Let's double chocolate chip equals to DCC, chocolate chip macadamia equal to CCM, original chocolate chip equals to OCC. Amira bought 4 DCC, 3 CCM and 6 OCC for 50 ringgit. Next, 2 DCC, 5 CCM and 9 OCC for Khairul and priced at 57 ringgit. Then, 6 DCC, 2 CCM and 5 OCC were bought by Humaira, with the total amount of the item being 53 ringgit. Let's find the price of each item they buy.
We move on to the calculation. First, we need to make 3 equations. First equation is 4x plus 3y plus 6z equal to 15. And the second one is 2x plus 5y plus 9z equal to 57. And the third equation is 6z plus 2y plus 5z equal to 53. Then we apply Cramer'S rule that ax is equal to b, that's the formula. And we divide to 3 columns. And first column in first row is 4, 3, 6. And second row is 2, 5, 9. And the last one is 6, 2, 5. And the second column is in one column, x, y, z equal to 15, 57, and 53. Then for the determinant A is in determinant, first row is 4, 3, 6, 2, 5, 9, and 6, 2, 5. Next, we do coefficient expansion along column 1. So for the column 1 is A11 multiple C11 plus A12 multiple C12 plus A13 multiple C13. So for the A11 C11 is 4 in the determinant 5925 minus 2 in the determinant 3625 plus 6 in the determinant 3659. And we need to expand for the each column and minus it. Then for the last result we got 4 multiple 7 minus 2 multiple 3 and plus 6 multiple negative 3. And we expand it again and get to 28 minus 6 minus 18. And the answer for the determinant A is 4. Then we need to use determinant AX for the x. We replace the first column with the answer that we put 15, 57 and 53, and the column 2 is 352 and the column 3 is 695. And we use coefficient expansion along to column 2. For the column 2 is negative A12 multiple C12 plus A22 multiple C22 and minus A32 multiple C32. And we put it in the A12 and C, and we got negative 3 in determinant 57, 9, 53, 5 plus 5 in determinant 15, 6, 53 and 5 and minus 2, 15, 6, 57, 9 in determinant. After we expand it and minus for the each column, we got negative 3 multiples negative 192 plus 5 multiple negative 68 minus 2 multiple 108. And after we expand it, we got 517.6 minus 314 and minus 216. And the final answer for the determinant x is 20. Then we apply this formula to the AY determinant. For the AY determinants in determinant, we replace for the column 2. So the column 1 is 4, 2, 6. Column 2, the answer we replace with the answer is 15, 57, and 53. And column 3 is 6, 9, 5. For this AY determinant, we use cofactor expansion along to column 1. For the column 1, we apply for A11 multiplied C11 plus A21 multiplied C21 plus A31 multiplied to C31. After that, we need to fill it the A11 and C11. So we got 4 in determinant, 57, 9, 53, 5. Minus 2 in determinant, 15, 6, 53, 5. Plus 6, 15, 6, 57, 9 in determinant. So after we expand it and minus, we got 4 multiple negative 192 minus 2 multiple negative 68 and plus 6 multiple 108. And after we multiply for the each column, we got negative 768 plus 139 and plus 648. And for the last answer for the determinant AY is 16. Then we apply to the AZ2, AZ determinant. For the determinant AZ, we replace the answer in the column 3. So for the column 1 is 4, 2, 6, column 2 is 3, 5, 2. In the last column, we put the answer is 15, 57, and 53. Then we use cofactor expansion along to column 2. For the column 2 is negative A12 multiple C12 plus A22 multiple C22 minus A32 multiple C32. Then we put A12 and C12. Then we got negative 3 in determinant 2, 15, 7, 6, 53 plus 5 in determinant 4, 15, and 6, 53 minus 2 in determinant 4, 15, and 2, 57. Then we expand it and minus it. So we got negative 3 multiple negative 236 plus 5 multiple negative 88 minus 2 multiple to 128. Then we expand for the each column. We got 708 minus 414 minus 256. And for the last answer for the determinant AZ is 12. Then we need to divide for the each x, y, z. For the x is determinant AX divide determinant A. For the y, determinant AY divide determinant A, and Z equal to determinant AZ divide determinant A. For the AX, we put it the value for the each determinant. So x equal to 20 divided 4, and we got 5. For the y, we got 16 divided with 4, and we got 4. For the z, we divide 12 and 4, and we got 3. For the final answer, we got x equal to 5, y equal to 4, and z equal to 3.
Based on the problem statement, we want to find the price of each flavor they buy. The price of each flavor they buy was estimated by Cramer'S rule. Cramer'S rule shows us that the method to solve for each unknown by finding the ratio of the determinant of AT to that of the determinant of the coefficient matrix. The matrix AJ is found by replacing the column in the coefficient of xj with constants of the system. Let x be double chocolate chip (DCC), y be chocolate chip macadamia and CCM, and z be original chocolate chip (OCC). For matrix A1, remove the column of the coefficient matrix A, which holds the coefficient of x, and replace it with the corresponding entries in B. For matrix A2, replace the column of A, which corresponds to the coefficient of y, and with the constants. And for matrix A3, replace the column of A, which corresponds to the coefficients of z, and with the constants. When we get the answer for each determinant, which is determinant of A is 4, determinants of A1 is 20, determinants of A2 is 16, and determinants of A3 is 12. After computing the determinants, we can find the price of each x, y, and z by dividing each determinants of A1, A2, and A3 with determinants of A. Hence, we got the price for each flavor, which is DCC is 5 ringgit, CCM is 4 ringgit, and OCC is 3 ringgit. We can conclude that the problem can be solved by using Cramer'S rule.
For the last one is conclusion. Overall, we can conclude that The linear equation will be much easier to solve by using Cramer'S rule. It is very efficient and perfect method to find the solution in the matrix. For example, it allows us to solve a system of equation for one variable independently without having to solve for all variables. As a result, we can figure out how to apply linear algebra to our advantage in daily life.